Here is another example of how we can use route tagging. In this particular example, what we're showing you is that we can use route tagging to make sure that if we are performing redistribution at multiple points in the network, we can ensure that this network here, the 12 network, does not go like this. Right? We don't want to relearn about the 12 network as an external route when it's already an internal network. The same thing is true going this way. What about the 11 network? We don't want to accidentally do this because of these 2 points in our environment where we are performing that redistribution. Because if this happens, we might have suboptimal routing whereby we want to reach, let's say, the 11 network from right here. All of a sudden, we go this way because of this routing loop redistribution that has occurred in our environment. And we don't want that to happen at all. We do not want to route or send traffic out of the particular routing domain just to come back in on another router. So what we can do is we can use these tags to control the redistribution that's happening. In this example, we are taking the 12 network that we see right here, and as we redistribute it into RIP, we are going to give it a tag of 40 in the RIP environment. So as RIP sees the 12 network, it sees it as a tag of 40. And as a result, when it comes back around and R2 eventually learns about it, and we perform redistribution on R2 back into EIGRP, we can say in the route map, we might be calling it the redistribute route map. So route map, redistribute, deny 10, match, tag 40. And since it's a deny sequence, it means do not redistribute those routes with a tag of 40. So now we are, as we see here, denying it from coming back in. So the 12 network won't be redistributed back into the EIGRP environment. So we can control it that way. Some of you might be thinking, well, wait a second, that's not really going to happen in this example, so we don't really need to do this. And I agree with you on that, because if we look at this in a little more detail, we understand based on administrative distance that R2 is going to learn about this network with an administrative distance of 90 and an administrative distance of 90. When it gets redistributed into the RIP environment, it's going to have what? An administrative distance of 120. So R2 sees it as 120. Now, is R2 going to redistribute the 1200 network back into the EIGRP environment? No, it's not. And the reason why is because you remember, you only redistribute those routes that are where? In the routing table. So is this one in the routing table? No. This one's in the routing table. Therefore, we won't be redistributing back in anyways in this particular case. But you might end up in a complex routing infrastructure with multiple routing domains, and at some point, because of potential overlap, next thing you know, you end up in a situation where that EIGRP route is coming all the way back around, or that OSPF or RIP network is coming all the way back around. Be able to recognize that and know that you could simply apply some tags and then filter those tags at the redistribution points, and you can solve that loop and prevent it from happening.